So, have you ever wondered how the most complex apps you use every single day actually work? We're talking about the magic that lets them scale up and stay reliable. Well, today we're going to pull back the curtain on the architectural pattern that makes it all possible: event-driven architecture.
I mean, just think about a food delivery app for a second. You place an order, right? And instantly, the restaurant gets a notification, a driver is found, your payment goes through, and you're getting live updates on your phone. It's a ton of moving parts, all happening at the same time. How does a system like that not just completely fall over? Well, that's the big question we're going to unpack.
Okay, so here's our game plan. First, we've got to understand the old way of doing things, the traditional request cycle. Then we'll shift gears and start thinking in events, which is the core idea here. That'll lead us to the real superpower of this whole thing: decoupling. And finally, we'll see how this sets us up to build some truly amazing things for the future.
All right, first up, let's rewind a bit and talk about the model that probably feels pretty familiar to a lot of us. This is that classic step-by-step process that basically ran the web for years. It's predictable, sure, but as we'll see, it's got some pretty serious drawbacks.
So this is what a typical request and response cycle looks like. See how it's just a straight line? It's like a row of dominoes. A request comes in, and then bam, it has to go through every single one of these steps in a very strict order. Each step has to finish completely before the next one can even think about starting.
The key phrase here is tightly coupled. Everything is locked together. Every step is depending on the one that came right before it. So, what happens if just one of those dominoes wobbles and falls over? Let's say the data conversion fails. That's it. The whole chain breaks. The entire request fails. For a big, busy app, that's a huge problem. So, if that old chain model is so fragile, there's got to be a better way, right? Of course there is. And that brings us to this idea of thinking in events. We're about to make a huge shift here, moving away from a world of direct commands and into a world where different parts of a system communicate by just announcing that something happened. So what is an event? It's actually super simple. It's just a little record, a fact that something happened. That's it. An item was placed in a cart, a user logged in, a payment was confirmed. These are all events. Notice they aren't commands telling something else what to do. They're just statements of fact.
Now, pay close attention here, because this is critical. Look at what this new order event doesn't have. There's no customer name, no address, no list of items they ordered. It only has IDs. The event is intentionally lightweight. It's not trying to carry all the data around. It's just a tiny notification that gives other services just enough info to go look up the details if they care to.
Okay, this table really puts it all into perspective. On the left, you've got the old request-driven way. Everything's tightly coupled and synchronous, meaning you ask for something and you have to wait for the answer. But over on the right, with event-driven, it's the total opposite. Services are loosely coupled. Communication is asynchronous. You just fire off an event and move on. And crucially, the service that creates the event has no idea who or what is listening.
And that idea, that services don't need to know about each other, that's called decoupling. And honestly, this is the magic trick. This is the superpower of this entire architecture. So let's dig into why this is such an absolute game changer. I love this analogy. Just picture a huge, bustling city. The person sending a package, they don't need to know the mail carrier's name or their exact route. They just drop the package in the mailbox. The city's postal system, which is kind of like our message broker, it handles everything else. That's exactly how these decoupled services work.
And when you run your system like a city, you get these incredible advantages. Want to add a new service? It's like a new business opening up. It doesn't disrupt anyone else. If one service gets really busy, you just add more resources to it. You don't have to scale the whole city. And here's the best part. If one service fails, if one business closes for the day, the rest of the city just keeps on running. That's real resilience.
And hey, don't just take my word for it. This chart really drives the point home. Look at the massive advantages for these decoupled systems in 3 key areas: scalability, resilience, and extensibility. Compared to the old monolithic way of doing things, the difference is just huge.
So let's bring this all together. We've gone from this brittle, fragile chain of dominoes to a dynamic, resilient city of services. Let's just put a nice bow on what we've learned.
So if you walk away with one thing, let it be this definition. Event-driven architecture, or EDA, is a way of building systems using a bunch of small, independent services that talk to each other by publishing, consuming, or routing these little messages we call events. And what does all that get you?
The ability to build solutions with not just a handful of services, but potentially hundreds of them, all working together in harmony, but independently. This is the blueprint for how the modern internet works at a massive scale.
So I'll just leave you with this final thought. Instead of being stuck in a rigid structure where one little change could bring the whole thing crashing down, what could you create if every single piece of your application was free to change, to scale, and even to fail all on its own? The possibilities there are pretty incredible to think about. Thanks for tuning in.